Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2019 Test 2A Paper 1 Code C&D Physics. Let's move to question number 1. In question number 1, a capacitor of capacitance C is equal to 2 microfarad is made of two large plates that are close to each other. Initially one of the plates has a charge Q while other was neutral. The entire space between the plates is filled with a slab of resistance 4 ohm. Find time during which Q square by 32C amount of heat energy will be lost in this slab. So it is given that these are the plates of capacitor and Q charge is given to this plate and this plate is neutral. So if initially this is the charge, then charge distribution will occur and the Q by 2 charge will come to the outer surfaces. So this is Q by 2. So the charge on this plate, on this side of this plate is minus Q by 2 and on this side is plus Q by 2. So I can say that at t equal to 0, the charge on the plates which are facing each other is Q by 2. So initial charge on the plate of capacitor I can consider Q by 2. Now it is given in the question that the entire space between the plates is filled with a slab of resistance 4 ohm. So this space is filled with a resistance R is equal to 4 ohm. So if I make the circuit representation of this, then I can say that suppose this is a capacitor C and the charge on the plates of capacitor is plus Q by 2 minus Q by 2 at t equal to 0, and these capacitors are connected with the resistor and the resistance of this resistor is given as R, which is 4 ohm. Now we have to find out the time during which Q square by 32C amount of heat energy will be lost in the slab. Let the final charge on the plate of capacitor is Q final. So on applying the principle of conservation of energy, initial energy stored in the capacitor minus final energy stored in the capacitor, so that is equal to heat loss, that is delta H. So if I substitute the data, initial energy stored in the capacitor is half Q, that is Q by 2 whole square by C minus half Q final square by C is equal to heat loss, that is Q square by 32 C. So on solving, the value of Q final comes out to be root 3 by 4 into Q. So this is the case of discharging RC circuit. So if I write the formula QF is equal to Q0 into e to the power minus t by RC, then from here I can calculate the time. So the Q final at that moment is root 3 by 4 into Q. Q0 is Q by 2 e to the power minus t by R into C. So in solving this, the value of t comes out to be RC by 2 ln 4 by 3. So if I substitute the value of R and C, then I can check the value of R is 4 ohm and the value of C is 2 microfarad, that is 10 to the power minus 6 divided by 2 ln 4 by 3 second. So if I write in terms of microsecond, then I can say that option A is the correct answer. So the correct answer for question number 1 is option A. Let's move to question number 2. Question number 2, 2 point charges Q and Q0 are placed at some distance. One of the electric field lines due to this charge configuration is shown in the figure in graphical form. Find the value of modulus Q0 upon Q. So in the given graphical form, we are observing that one of the electric field lines is originating from one charge and terminating at other charge. So one charge is positive and the other charge is negative. Let I am considering this charge as positive and this charge as negative. The length of one unit is R. Then this separation can be considered as 3R and this separation can be considered as 7R. Similarly, this separation can be considered as 4R. So if I draw this diagram here, suppose this is charge Q and this is charge Q0 and this is the point P and this separation is 4R, this is 3R and this is 7R. So in that case, So we have chosen charge Q as positive and Q0 as negative. Then the electric field at point P due to charge Q is in this direction. Let it is E1. And the electric field at point P due to charge Q0 is in this direction. Let it is E2. Suppose this angle is phi 1, then this angle is also phi 1, and let this angle is phi 2, then we can say that this angle is also phi 2. So if I apply the geometry, if this is 3r, this is 4r, this would be 5r, and this separation would be root 65 into r. Now if we see the graphical representation of the electric lines of force, then at this point the electric lines of force is horizontal. It means the net electric field intensity is in this direction. So the component of the electric field in vertical direction must be equal to 0. So on equating E1 sin phi 1, so this angle is phi 1, then this angle is also phi 1. So E1 sin phi 1 is equal to E2 sin phi 2. So the value of E1 is 1 upon 4 pi epsilon naught Q divided by R square, that is 25 R square into sin phi 1. So the value of phi 1 is 4 by 5 from the geometry, that is equal to E2 1 upon 4 pi epsilon naught Q naught divided by separation, that is 65 R square into sin phi 2, and the value of sin phi 2 is 4 divided by root 65. So on solving, the value of Q0 by Q comes out to be 13 under root 65 divided by 25. So option B is the correct answer. Let's move to question number 3. In question number 3, 4-point charges Q are fixed at the corners of a square of side length A. Another point charge capital Q having mass small m is placed at a distance A from the center of a square perpendicular to the plane of square. If charge Q is in equilibrium, then suppose I am considering this point charge and this charge. Let this is the position of this charge Q, and the position of charge capital Q is here. This separation is A by root 2 and this separation is A. So this separation R can be written as A into root 3 by 2. So the electric field at this point due to charge small q is in this direction, and let this angle is theta, then this angle is also theta. So if charge capital Q is in equilibrium, then we can say that the gravitational force acting on this charge Q in this direction, that is mg, must be balanced by the net electrostatic force acting on the charge capital Q. So that is equal to capital Q into the net electric field at that point in vertically upward direction. So that is equal to 4 times E sin theta. So on substituting the value of E, we can write mg is equal to 4q into the electric field at the location of capital Q due to small q charge. That is capital Q into small q divided by r square. So it can be written as a square into 3 by 2 into sin theta. So from geometry we can find out the value of sin theta. So it comes out to be under root 2 by 3. So under root 2 by 3. So on solving, the value of m comes out to be 8 root 2 k capital Q small q divided by 3 root 3 a square into g. So we can say that option B is the correct answer. So the correct answer for question number 3 is option B. Let's move to question number 4. In question number 4, PV graph for a certain cyclic process of an ideal gas is given. The process C2A is isothermal. Choose the most appropriate VT diagram corresponding to this PV diagram. So in the question it is given that from process C2A is isothermal, and from the diagram we are shown that the process B2C is isobaric. So let's check initially these two processes. So from B2C, the process is isobaric of given ideal gas. So if I see the VT diagram, then in case of isobaric, pressure is constant, then V is proportional to T. And when V is proportional to T, as the volume is increasing, temperature must rise. So if I see the linear relationship between T and V, then B2C, this is the correct, then this is wrong, and this is correct. So till now, option A and option D may be right. Let's check the process from C2A. In the process C2A, it is isothermal. Temperature is constant and the volume is decreasing. This is correct. Temperature is not constant. It is also decreasing. So option A is wrong. So option D is correct till now. Then from A to B, it is some process in which pressure is decreasing and volume is increasing. So the process A to B is some polytropic process, which is specifically not clear. So if the volume is increasing, here is also the volume is increasing. So A to B, this is correct. So I can say that the most appropriate VT diagram for the given PV diagram is option D. So the correct answer for question number 4 is option D. Let's move to question number 5. In question number 5, consider a neutral metallic sphere centered at O. A point charge Q is placed at a distance B from the center O of the sphere as shown. Net potential at point P is equal to. So it is given in the question, it is a metallic sphere. So in case of a metallic sphere, whatever is the potential at the center of the sphere, at every point of the sphere, the potential remains same till the surface. So I can say that the potential at point P is same as the potential at point O. So due to the presence of charge Q in the vicinity of this metallic sphere, there is induction on the surface of metallic sphere. So some minus charge will come on this side and some positive charge will non-uniformly distributed on this side. Let I have considered charge Q as positive. But one thing is sure, the potential at point O due to these induced charges will be 0. So the net potential at point O is only because of Q, and that can be written as 1 upon 4 pi epsilon naught Q by B. So option C is the correct answer. So the correct answer for question number 5 is option C. Let's move to question number 6. In question number 6, molar heat capacity of an ideal monatomic gas in the process P square into T equal to constant. And it is given in the question that R is a universal gas constant. So it is a polytropic process. So I am converting this process in the form of PV raised to the power X is equal to constant. So I can write P square into T, since it is an ideal gas, so T can be replaced by PV into constant. So it can be written as P into V ki power 1 by 3 equal to constant. So from here we can compare and get the value of X, that comes out to be 1 by 3. So in the case of polytropic process, this we can directly write the molar heat capacity of an ideal gas. So C is equal to Cv plus R divided by 1 minus X. So the value of Cv is 3R by 2 plus R divided by 1 minus X. So on solving, the value this comes out to be 3R. So option C is the correct answer. So the correct answer for question number 6 is option C. Let's move to question number 7.